Hello, good morning students, and welcome back to another video for the laws of motion and the exercise. So the first question that we have today is, why do we fall in the forward direction while moving bus brakes to a stop and fall backwards when it accelerates? So the question states that you might have experienced this in a bus, that whenever the bus is moving and you are standing, and when the bus applies the brakes, you are falling forwards, because what happens is your body wants to keep moving. Similarly, when the bus is standing and suddenly it starts to accelerate, we fall backwards. Why? Because now our body is in rest and the bus has started moving. So our feet are going along with the bus, and therefore the rest of the body wants to fall down. This happens because of the inertia. That is the first topic of the chapter that we studied. Inertia is the property of the material or the substance. Okay, so what happens is, let me explain it to you. Suppose this is the bus, okay, and it is moving, and you are standing over here inside the bus. It is moving forward. So what happens is your body is also moving forward along with it. Now, as soon as the brakes are applied, the bus stops. The bus stops moving. Okay, so now it is at rest position, and so the feet which are along the bus, they also stop. But your body has not stopped. It still wants to keep moving because of its inertia. Because of its inertia, and in this case, the inertia is constant velocity, or whatever the velocity of the bus, constant velocity of bus. So whatever the velocity of the bus, it is the velocity of the person standing inside also. And so it because of the inertia, the body wants to keep moving in its velocity, but the feet has stopped, and therefore the body falls down. Similarly, when the bus is standing still, and you are also standing along with the bus, so your body is in rest position. Now suddenly when the bus starts moving, the feet which are on the bus also wants to move, but the body is on the rest, in the rest position, and therefore we fall down, because the feet are moving forward and our body wants to remain in rest position. And this is all happening once again because of inertia. In this case, the inertia of the body is rest position. I hope it is clear to you, students. This is a theoretical question. You can answer it in your own words, that this phenomena happens because of the inertia. Okay. In the first case, inertia is the motion of the body. In the first case, it is inertia of motion of the body. It wants to remain in its velocity. Okay. And in the second case, inertia is rest position. In the second case, inertia is rest. Okay, so the body wants to stay in rest position, but the bus keeps moving, and therefore because of the feet which are with the bus, they move forward, and therefore your body tries to fall down. Quite simple actually. You can answer it in your own words, but remember to mention inertia and the constant velocity or the velocity of the bus along with the person. Okay, very simple. Second question is, if action and reaction are equal and opposite, then explain how horse can pull a cart. So in this case, what is happening is, a horse is trying to pull the cart behind it. Okay, a cart behind it. A horse is trying to pull a cart behind it. So it is applying the action. So where is the reaction? So in this case, if you remember, when we studied the motion chapter, laws of motion, the first thing that we studied was static friction, if you remember. Right? Static friction, that you remember. So when we are applying the force, the static friction of the cart is applying the force in the opposite direction. Okay, the static friction of the cart is applying the force in the opposite direction. Just like when we studied the law of conservation of momentum, if you remember, one ball is striking another ball. So this ball starts moving, but at the same time the velocity of this ball decreases, because at a certain time this ball stops and this ball keeps moving, because it has given some of the velocity to this one, and this one has applied the force in the opposite direction, so that this ball has decreased its velocity. So similarly, what is happening? The cart or the horse is applying the force on the cart, and the cart is applying the opposite force in the opposite direction to make it stop. And the another thing is the horse is moving forward. So with the help of its legs, it is applying the force on the surface of the road. So what is happening? It is applying the force on the road, and the road is applying the force in the opposite direction. So the horse is applying the force in this direction, and the road is applying the force in this direction, which is why the horse is able to move along with the cart. So in this particular case, there are two things happening. The horse is applying the force on the cart, and the cart is applying the force in the opposite direction because of static friction. Okay, because of static friction. And to overcome that static friction, the force applied by the horse is even more. So the horse has to apply and struggle more to overcome the static friction. Okay, once it has overcome, the sliding friction is less, or the rolling friction is less. But in the very beginning, when it wants to move, the static friction is more. So it has to apply more force. And the other thing is, the horse has to apply the force on the ground while it is moving. Just like when we are walking, we are applying the force on the ground. So the force is applied in the opposite direction, and the ground applies the force in this direction. So this is action, and the horse itself moves forward. It is reaction. So these two are acting at the same time simultaneously. Okay, so the horse applies the force on the ground, that is action, and the ground applies the force on the horse, that is reaction. So once again, the Newton's third law of motion comes into play. Okay, the third one is something different. Explain why is it difficult for a fireman to hold a hose pipe which ejects large amount of water with high velocity. Once again, now this is the example of the third law of motion. If you know, firefighters use this very huge pipes which ejects a lot of water with very high force or very high velocity. Okay, because they have huge motors in their engines, and because of which they pump the water with very high velocity because they have to overcome the fire. So let's imagine that over here there is a fire and they want to extinguish it. So they use those pipes, and in that very high velocity water starts coming out, okay, from the pipe, and they have to hold this hose pipe very firmly. Why? Because the velocity and the force with which the hose pipe comes out, the water comes out, the hose pipe wants to go in the opposite direction. This is just the simple case of the third law of motion, that is action and reaction. If you remember, we studied about a gun. Okay, so if suppose this is the gun and the bullet comes out from this direction, then the gun also experiences the force in the opposite direction, that is the jerk, okay, which we call recoil. Okay, so when the bullet comes out from this direction, the recoil is experienced in the opposite direction. So the person has to hold the gun very firmly. This is exactly the same thing that is happening over here. Okay, so the water comes out with very high force and velocity, and therefore the pipe wants to go in the opposite direction. Or you can also take the example of the rocket. The fire and the force that comes out from the exhaust is so high that the force in the opposite direction is also high, and therefore the rocket keeps moving in the upward direction. So this is action, and because of which the rocket moves upward is reaction. So same thing is happening over here. The water with which the comes out is very high velocity, and because of this the reaction is in the opposite direction, because of which the fireman has to hold the hose very firmly. Okay, this is also happening once again because of third law of motion. Don't forget that. The question asked is the same thing. Why does this happen? Why does the fireman have difficulty in holding the water hose? This is because of the third law of motion, that the water comes out with very high force, that is action, and the pipe wants to move in the opposite direction, that is reaction. The pipe wants to move in the opposite direction, that is reaction. This is happening because of the third law of motion, and so that the pipe does not move here and there, the fireman has to hold the pipe in its position very firmly. Okay students, so once again what we saw today are the simple examples of the laws of motion. The first one was about the bus, that when a bus starts moving, we are also moving along with the bus, and when it stops, the body wants to move forward, but the feet has been stopped along with the bus, because our feet are on the bus and it has stopped along with the bus. So what happens is, imagine this, that this is the bus and my pen, it wants to move forward, and as the bus stops, the body also wants to move, but the feet has stopped and therefore it falls forward. Similarly, when the bus is standing still and our body is also in the rest position, so when it moves suddenly like this, so our whole body wants to fall backwards, but the feet keeps moving with the bus. I hope it is clear to you. In the same way, the second one was about the action and reaction, that is the horse and the cart. The horse moves forward, it applies the force on the ground in this direction, that is action, and the ground applies the force to the horse in this direction, that is reaction, similar to how we are walking on the road. And the third one is about the water pipe and the fireman, that when the the water comes out with high velocity, it applies a lot of force in this direction, that is action, and the pipe wants to move in the opposite direction, that is reaction. This happens because of the third law of motion. I hope it is clear to you, students. We'll talk more about this chapter in the next video. Till then, have a nice day.